Hello children, in this video we learn about square and its properties.
Square of a number. The meaning of square of a number is if a number is multiplied by itself, then it is known as the square of a number. For example, 2 square. It means we are doing a square of 2. So here 2 is multiplied by 2. Then we get the 4. 3 square. It means 3 is multiplied by 3. So if we multiply a number by the same digit, then we get the square of a number.
Square or square number. When we do the square of a number and the number which we get is known as a perfect square or square number, or we can say that a natural number is a perfect square if it is the square of some integer. It's mean when we are doing the square of an integer, the number which we get is known as the perfect square or square number. For example, we are doing the square of 2. So we get 4, and this 4 is known as a square number. Similarly, another example, if we are doing the square of 5, we get 25. 25 is a perfect square or square number.
There is a table of a square 1 to 20 which we have to learn. This makes our equations or problems to solve very easily. Properties of square numbers. If we observe this table, we find there is no digit 2, 3, 7 or 8 at units place. Look at there. Here units digit 1, 4, 9, 6, 5 and 0. So there is no digit which having end with units digit 2, 3, 7 or 8. It's mean we can say that a number having 2, 3, 7 or at units place is never a perfect square. Second point, the number of zeros at the end of a perfect square is always even. We can understand it by an example like that. 10 square, it gives 100. 20 square, it is 400. 1000 square, it is 10 lakh. So we are observing that a number which is having zeros as odd. This is 0. There is a number of 0 is 1 which is odd number. And after doing the square we get 100. It's mean number of zeros even. So the meaning of saying that a number ending in odd numbers of zeros is never a perfect square. Square of even numbers is always even. Suppose we are doing a square of 2. This is 4. Even number and its square is also even. 6 square, 36. 6 is even, its square is also even. If we are doing a square of odd numbers, that will be odd. 7 square, this is 49. 7 is an odd number, its square is also an odd number. So if we are doing a square of even number is even, and if we are doing a square of odd number is always odd. A square number will end with digit 1 only and only when the number of it is the square and with the digit 1 and 9. We consider it as, let us, we are doing a square of 11. This is 121, and we are doing a square of 9. This is 81. So here in the square number, the digit end with 1 only and only when in number it is ending with 1 or 9. Second point, a square number end with digit 4 only and only when the number of which it is square either end with 2 or 8. So we can understand it as, if we are doing a square of 2, this is 4. If we are doing a square of 8, this is 4. So square number is ending with 4 only and only when it is the square of ending digit with 2 and 8. Next one. A square number will end with digit 5 only and only when the numbers of which it is square end with digit 5. Suppose we are doing a square of 25. This is 605. It is ending with 5 only and only when we are doing a square of digits ending with the number 5. Let us consider 15 square. This is 225. A square number will end with digit 9 only and only when the number of which it is square ends either with digit 3 or 7. A square number ends with digit 9 only and only when it will end digit 3 and 7. Let us doing the square of 13. This is 169. 7 square. This is 49. At units plates 9 in a square only and only when a square of a number end with 3 or 7. Next point, a square number end with digit 6 only and only when the number of which it is square and with digit 4 and 6. So we are doing a square of 4. This is 16. If we are doing a square of 6, this is 36. Both the square end with 6 and 7 when we are doing a square of units digit ending with 4 and 6. A square will end with digit 0 only and only when the number of which it is square and with digit 0. If we are doing a square of 10, this is 100. So in a square number, a digit come 0 at units place when we are doing a square of digit ending with 0.
Now look that and is equal to 1. So there is a one odd number and that is the square of 1. And we write the two odd numbers. This is 1 and 3. So this is square of 2. The meaning of saying that how many odd numbers starting from the 1 we write, then it will be to the square of the that numbers. How many numbers odd we have been written. Suppose next 1, 3, 5. There are 3 natural numbers. So this is square of 3 square. Next, 1, 3, 5, 7. There are 4 odd natural numbers, so this is also square of 4. In the same manner, if we are writing 1, 3, 5, 7, 9, 11, there are 6 odd numbers, so it will be a square of 6. It's mean that numbers should be started from the 1, 2 as a successive odd natural numbers. If it is not starting with the 1, then it will be not a perfect square. It is a reverse method of successive odd natural number. We apply this method to know a number which is given to you perfect square or not. For this, suppose an example is given to you 25. Now we subtract 1. So we get 24. From 24 we subtract another odd consecutive number. This is 3. So we will get 21. 21 minus 5 we get 16. 16 minus 7, 9. 9 minus 9 is equal to 0. If at the last after subtraction we get the 0, it's mean the number which is given, it is a perfect square number. Next example, 34. Similarly, we do that. We subtract the successive odd numbers. We starting with the 1. 34 minus 1, 33. 33 minus 3, 30. 30 minus 5, 25. 25 minus 7, 18. 18 minus 9. 9 minus 11 is equal to minus 2. Now we look there that we are not getting 0 after subtraction. It's mean 34 is not a perfect square. So to check whether is it perfect square or not, we subtract odd successive natural odd numbers.
Pattern 3. If we are doing the square of any odd natural number other than 1, it can be expressed as the sum of 2 consecutive natural number. अगर हम किसी ऑड नेचुरल नंबर का स्क्वायर कर रहे हैं तो इसको हम 2 कंसेक्यूटिव नेचुरल नंबर्स के फॉर्म में एक्सटेंड कर सकते हैं. सपोज दिस इज 3 स्क्वायर. 3 स्क्वायर मीन it is 9, and 9 can be written as by 2 consecutive natural numbers. This is 4 and 5. 5 square, this is 25, and this can be written as 12 plus 13. We can consider it as also, suppose this is 4. How we get it? 3 square minus 1 divided by 2. This is 9 minus 1. This is 8 upon 2. So we get it 4. This is 5. This is 3 square plus 1 divided by 2. It's mean 10 upon 2. Then we get 5. This is the pattern has been applied in that. Let us consider the next number square. This is 5 square. This is 12. It's mean 5 square minus 1 upon 2. The square of 5 is 25 minus 1, 2. This is 24 upon 2. So we get this is 12. 13. Similarly, this is 5 square plus 1 divided by 2. So this is 26 upon 2 and we get 13. So this is the pattern to write an odd natural numbers in the sum of 2 consecutive natural number. Pattern 4. Product of 2 consecutive even or odd natural number. If we are doing a product of 2 consecutive even or odd natural numbers, so we can solve it by doing a square of number between these 2 consecutive numbers and subtract 1. So let us consider an example, 11 into 13. These are 2 consecutive odd numbers, and between these 2 consecutive numbers 12 will lie. So we will do the square of 12 and minus 1. This is 144 minus 1, which gives 143. If we do the multiply 11 and 13, this is also give 143. Similarly, if we are doing a product of two even numbers which are consecutive, 16 and 18, the number would lie between 16 and 18, this is 17. So we can write this as 17 square minus 1. In general, we can say that a square minus 1 is equal to a minus 1 or a plus 1. Next pattern, pattern number 5. Square of natural numbers ending with digit 1. We are doing a square of 11. This is 121. We are doing a square of 1, 1, 1, 1, 2, 3, 1. If we observe this pattern, we find the numbers of digit in a square number, suppose 3. So when we are doing a square of this, we will write 1, 2, 3. How many numbers are in the square? So again we write in a square number 1, 2, 3, and then after decreasing the number in reverse order 2, 1. Similarly, there are 4, 1. So first of all we write 1, 2, 3, 4. Now we will decrease the numbers 2, 3, 2, 1. Another, we can take it the numbers of 1, 6. So first of all write 1, 2, 3, 4, 5, 6. Now decreasing 5, 4, 3, 2, 1. So this is a pattern. By this we can find that square of the numbers which are having only 1.
There is a one more pattern. Here is given 11 square is 121, 101 square 10201. Next 1001 square, this is 1002001. Here we have noticed the pattern. The right side of the equality has an odd numbers of digit. First and last digit is 1. First and last digit is 1 and the middle digit is 2. In the left side and the right side of the middle digit 2, numbers of zeros are as given in the number of which we are doing a square. We can see that there is a number 1001 square. So in the first we have written 1, at the last we have written 1, and the middle term is 2. And to the left side of the middle term there are as numbers of zeros 2 as given in this, and the right side the numbers of zeros is also 2. Another, we can look an example 100, there are 1 4 zeros and 1. Now we look for that pattern. First digit also 1 and last is also 1, and the middle term is 2, and to middle term to the left side number of zeros is 4 as given in the number, and to the right side the number of zeros is 4 as given in the number.
There are two and non-perfect square numbers lie between two consecutive square numbers n square and n plus 1. Let us consider an example by which we can understand it very easily. For example, 4 square, this is 16. 3 square, this is 9. So we can write, understand as 3 square is equal to n square and 4 square is equal to, this is increasing by 3, 1. So this is n plus 1 square. Now we write the numbers between the square of 3 and square of 4. It's mean between 9 and 16. So this is 10 to 15. There are 6 numbers, and how we get it? This is by 2n. So what is n? N is 3. 2 into 3, which gives 6. So there are 2n non-perfect square numbers lie between two consecutive square numbers. There is a rule to find the square without multiply. We are taking an example. This is 47. We have to find the square of 47. We can write this is 47 as 40 plus 7. Now we will apply an formula. A plus b का whole square is equal to a square plus 2ab and plus b square. Now consider here as a is equal to 40 and b is equal to 7. Substitute all these values according to this. Substitute a square. This is 40 square. It's mean this is 1600. 4 4 is 16 and 00. B square. It's mean 7 square. This is 49. 2ab. 2a is 40, b is 7. So this is 560. So we are getting 1600 plus 49 and 560. Sum of all them. This is 2209. So we can find the square without multiply of a number by putting all these values in that formula. This is a plus b whole square. Here is a rule to find the square whose units digit end with 5. Let us consider an examples. We have to find the square of 25. 25 square. This is units digit is 5. So how we will find its square? First of all, we do the square of 5. This is 25. Now we write this is 25. After that we comes on its 10th digit. That is 2. Now increase it by 1. This is 3. So multiply original digit 2 and increased by 1. This is 3. Multiply both the digit. This is 6. So we'll write at 100 place. This is 6. So the square of 25 is 625. Another example. This is 35 square. So first we do the square of 5. This is 25. Now increase 3 by 1. This is 4. Multiply original number to 4. This is 12. So this is 12 to 5. 1225. It is a square of 35. Similarly, we can find the square of the numbers which end with digit 5. Pythagorean triplet. In that we are having a 3 numbers like that the square of the greatest number is equal to the sum of the squares of 2 numbers. All the numbers will be greater than 1. If we put all the values in that formula, we will satisfy it by the Pythagorean triplets number. So the numbers Pythagorean are 2m, m square minus 1 and m square plus 1. Here is an example is given. We consider a number 14. Let us return 2m is equal to 14. So we have been written 2m is equal to 14. From there, we get the value of m, which is 7. Now we will find m square minus 1. So the m is equal to 7. Now m square minus 1, we will get this is 48. Again we find the value of m square plus 1. As we have been already find the value of m, this is 7. So m square plus 1 is 50. Now these all the numbers, which is 2m, m square minus 1, m square plus 1 are Pythagorean triplets number. So we'll write that 2m is equal to 14, m square minus 1 is equal to 48 and m square plus 1 is equal to 58. So the Pythagorean triplets number for m is equal to 7 is 14, 48 and 50.